For our project, our team was given an executable file and told to implement what is called a cheat onto it. A cheat in this context is a modification which provides predictable behavior that alters the original file's behavior in some interesting way. We were also told this file was non-malicious, and a quick run of the program revealed it to be Dance Dance Revolution Finger Edition. That is, a game with a series of arrows rising up the screen in which the player must hit the correct arrow key as it reaches the top of the screen to earn points. Given this context, a cheat, more specifically, alters the rules or experience of the gameplay. It was up to our project team to find the tools, obtain the resources, and learn the skills needed to understand the file and create a cheat with it.
So in the analysis of our executable file, our goal was to determine how we could see the user-written code and what programs we were going to use in order to see the code. So in doing that, our analysis was to use a broad to narrow search of the code, and we did that through Visual Studios first. In using Visual Studios, we were able to isolate the main functions and see where the user actually entered the code versus all the other libraries that we did not need to go through because they were just included in the file. So after we had a grasp of what the main function was doing and were able to isolate that, we needed to go to find better tools in order to edit the code. While doing that, we found a program called Ollie Debug, which allowed us to go through the disassembly and to actually manage breakpoints and to determine where certain calls were made and where we could break up certain pieces of code. And after we did that, we were able to implement the cheat, and we will go over that shortly.
The first step that we took in the analyzation was looking for user-written code. This was especially helped by our software giving us the entry point into the main function, where rather than looking at the included libraries, to really help us find the direction of the file rather than looking at code produced by other people. We had the advantage of dealing with a non-malicious file, which did allow us to run portions of the code, but many of our strategies are applicable to dealing with malicious executable files as well. Our first step in looking at the user-written code was to look for loop structures, as in many programs, the majority of the work is done by loops. And here, in this particular program, we found a master loop which ran the menus and the game, and inside an interior loop which ran the game itself. After this, we also started identifying function calls, especially those to outer sources, and analyzing what they did by looking at the arguments passed on and how the returned results were evaluated. This is, of course, helped by looking for comparison statements. Large blocks of comparison statements really help you tell what direction the program is going. In order to make sense of this all, it helps to start by identifying local variables that are passed on as arguments and those that are hold function results, and then seeing how they are compared. While this takes a lot of documentation, it may not make sense at first, as you go big picture, do this for the master loop, then do for smaller loops and smaller loops, patterns emerge, and you're able to deduce what each variable is doing and what the functions themselves are doing.
So in implementing our cheat into the executable, our idea was to enter a secret game mode at the menu at the beginning of the game. In doing so, the options for the user were for 1, to either play the game, or 2, exit. And when they would play the game using the option 1, the game would go on as normal, making the arrow keys increases points, missing the arrow keys decreases points. However, if the user entered the secret option of 3 at the menu, the game would start as usual, just as if they were playing it normally. However, when the user missed an arrow key and they entered the wrong arrow key, the points would not be deducted. So the user's score always gets gradually higher and higher as they continue to play on. And this was our implementation of the cheat.
In the traditional plane of the game, you enter 1, enter your name, choose your difficulty, and then you must hit the right arrow key. However, if you hit the wrong arrow key, you'll notice that your score quickly decreases. Clearly, this can be devastating. Playing the game again, we now choose our secret game mode. Now we're able to hit the arrow keys as quickly as we want with no penalty. While you may not achieve a perfect score, this allows you to easily trick your friends into thinking that you're much better at Dance Dance Revolution Finger Edition than you actually are. This allows someone to score much higher and much more easily than they normally would.
And we were able to implement this cheat by going into an area where memory was not being used and able to create more compares in order to determine what the score was as of right now. And when you checked what the score was, if it was in the secret gaming mode, the user would, or the program would just skip past the subtracting of the points. It would skip past and would not allow the score to change. However, this was done through a function call, and when it was time to determine if points needed to be deducted, the call was made, and the program would simply check if the user was in option 3 or option 1. And if they were indeed in option 3, the program would just skip the decrementing of the score. And this was how the cheat was implemented inside this